Hi, welcome to my channel about fish technique, robotics and embedded systems. The focus of this video is the ESP32 right here, which controls two motors, fish technique motor and ST90 servo motor, both driven by pulse modulation, and the other components are electronics. Last time I focused on a small circuit with both a physical switch, this one, and an electronic switch, being a transistor, and it didn't work out at all. Well, this one did, the physical one, but the transistor did not work out. And I just found out why. And to show you, I switched to screencast. When talking about transistor, you can look at something like this. However, this, which has more or less the same external properties, it is not a transistor. This is a temperature sensor. And I could have been warned or alarmed because in another project I experienced the same thing. I thought it was a transistor while it wasn't. So this is a temperature sensor and this is the transistor, which I actually need. So I am placing this one right here, and things are not powered up yet. This one is going, well, someplace else, but it can be used in another thing, or maybe right now, I don't know yet. Anyway, it's not, the whole circuit is not powered up yet, so this is not running, and this should be the circuit that is intended to be. Will it work out? I don't know yet. So this is the schematics as you are familiar with, or can be for Fritzing. Then this is the whole schematics, just as in a, well, as schematics can be. Then simulation, and this should give a graph with 5 volts over this transistor. Will it work? I'm not quite sure. Let's run it. And error during block parameters update. Okay, so I need to look into that a little bit further. Anyway, this is the real stuff, so I am going to connect the power to the circuit. And now things are connected. I can actually say, okay, port is on USB 2. And I can now actually upload, compile and upload, and if everything is fine, then I can also start the serial monitor, which I have to set to this speed. Almost done. Alright, so you can see here that this motor is working out, this not yet. But what I'm most interested in is this LED and this LED. This physical switch is set to on, so that should be no problem. Yes, this is working out, but this isn't. So let me put this switch to the other side and then see if things work out in the right way. Waiting for the beeper, for the buzzer. Then hopefully this one is working as well. No, it's not. Right now both motors work. So this one is nicely and this one is nicely working. But that is obviously not the focus of this video. That is this circuit. And you may notice that things are different right now. This wire is different. The position of this switch is different, and this wire is quite different. Reason is that I looked up a circuit, and then you have emitter, collector, emitter, base and collector, and you can find it easily on the internet. And it turns out that in the simple schematics that this switch is not connected to the emitter but to the base, and there's just one line to the emitter. So in schematics this is different now. Base voltage through switch, which is basically the control voltage to the base. Then the load is to the emitter, and then an LED to ground. This is still not correct, I find. So this one has to go different. This is the emitter, which has to go to this one. So I still need to connect reconnect some wires. So from here to here, and then from, let's say, here to, yeah, how to do the base. Let's move this one a bit. Doesn't make it very clear, but this one is like this. So the switch is here, and then this one, let's make it here, and a bend point, so I can take this one over here, another bend point, and this one too. Yeah, where exactly? Oops, everything is deleted. Not again. So let's put it here. So that's more realistic. However, does it work out? And that unfortunately it does not. So this one is still working. This one doesn't do anything as yet. And right now the algorithm is such that this one, that this port is not always working out. So I have to wait the whole algorithm in order to see the difference. If I switch this on, and I can notice, of course, if I put multimeter on, so that's next. So with the multimeter in place, set to voltage, full scale, 30 volts. I am checking here, which says 0 volts. I am checking here, it says 4 volts, that's good. And if I check here on the other side of the switch, it says 0. So I have to change the switch in position, and right then I check again and it says 4 volts. That means that if I get right here right now a voltage, that this should be functional, which it clearly is not. It didn't do a thing. So what I have to do is measure the voltage right here, wait for the buzzer and the other LED to signal, and wait for the needle to move, and then I know if the LED is actually receiving something. It is not. It is not receiving anything, so I have to move right here to measure if it is receiving something, because this is the collector and that should function. But does it? That is a very good question. Waiting for the LED and power, and it is not doing anything. So when this even doesn't do anything, the collector of the transistor, and here it is functioning, and here it should be functioning soon, then once again there is something wrong in the circuit, and maybe even with the transistor. Yep. And so I have voltage here, I have some voltage over here, I have voltage here, but not over here. And that means without voltage here, this LED will never work or never show. So no matter if I have some malfunctioning simulation, because unfortunately it has a malfunction in the circuit, then it still means that there is a hardware problem, which means that I can't do what I want with that circuit, which is simple enough, but failing hardware gives a grinding halt. I did not find any information on how to test the transistor, but if I take this probe and I'm measuring on one point from here, yeah, it does something. Here I measure something constantly because of this hardware switch. Here I measure nothing, and if I wait long enough until the first LED is lit, then I won't measure anything once again. But this shows that clearly the LED is working, although I'm now basically cutting out the transistor, and this shows it doesn't work. So there is something wrong, definitely wrong with this transistor. Most unfortunate. How to solve this? Well, get a replacement of for the transistor, and otherwise it is too bad that even a simple circuit as this is malfunctioning because of that. End of this story. And then it doesn't matter if I have this simulation which isn't working for some very strange error, which I am so far unable to solve. But nice try, let's put it that way. This is alright, and this is alright, and that's it for a transistor story. But up next video will be the temperature sensor. Different from this, so I have to check on that. Thank you for watching. If you like this video, please do subscribe to my channel, give the video a thumbs up. click the bell for notification. You can also follow me via Twitter and Instagram, and you can support via PayPal, Ko-fi, and by becoming a patron. For more nice things like this, please check my website listed under the video, and this is going to be continued. For now, have a great day, stay safe, take care, bye.